Hello students, today we shall be learning about binomial theorem for positive integral indices. It is a pretty interesting phenomena, as you must have learned in your previous classes. Let us take a few identities which you already know. Let me write down these identities as and also understand what goes behind all this writing. Let's say if I'm writing a plus b raised to the power 0, what would you say my answer would be? It would be 1. Anything to the power 0 is always 1. Let me take you to the next step. A plus b raised to the power 1 would always be a plus b. If I take a plus b to the power 2, you would say it is a square plus 2ab plus b square. Again, if I write a plus b whole cube, it would be a cube plus 3a square b plus 3 ab square plus b cube. Again, if I have to write a plus b raised to the power 4, it would be a power 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b4. Now this you can achieve it through two ways. Either you actually multiply it as a plus b whole cube into a plus b, or you can also do it a plus b whole square into a plus b whole square. Let us know a little bit more about it if we arrange it in certain fashion. Let's say all the powers are actually known as indices or index. Okay. So if your index was, let me write down what is our index and what are our coefficients of above expansion. So when index was 0, obviously my coefficient was 1. And if your index was 1, there were two coefficients, 1 and 1. If index was 2, what was the coefficient? It was basically 1 and then 2 and then 1 dot b square. So it is 1, 2, 1. And when we were doing it for index 3, what was my coefficients? They were again 1 and then 3 and then 3 and then 1. You can actually verify from on the top. They are, here it is 1, then 3 and then 3 and then 1. Hope you understand that. Again, my next coefficients are 1, 4, 6, 4 and then 1. So we would write them accordingly. So let's write them 1, 4, 6 and then again 4 and then 1. So here my index was 4. Likewise, if we really see this, let us, start writing it in a certain manner. What I can write this as, this one can be written as 0, C0. This here it was, index was 1. So we take index as 1. So beginning 1, C0, 1, C1. They hold the same value as 1 as 1. Similarly here, I have my index is 2. So what would I write here? 2C0. Here it will be 2C0, then 2C1, and then 2C2. So 2C0 is 1, 2C1 is actually 2, 2C2 is 1. I'm assuming that you have prior knowledge of permutation and combination, and you are aware about NCR and NPR. How you choose R objects out of N. Now again, if my index is 3, it would be 3C0 and then 3C1, 3C2, and then 3C3. Similarly, we can extend for index 4, and we would be writing 4C0, and then 4C1, 4C2, 4C3, 4C4. We notice that their corresponding value is same as the coefficients that we have already noticed. Now, such a thing can actually be enhanced and extended to a general formula of a plus b raised to the power n, and we could possibly extend it. Now, if we really see that this kind of whole thing, every time we raise an index, it keep on expanding, and this appears like a triangle, and this triangle is what is known as Pascal's triangle. Pascal's triangle. Now, based on this triangle, we possibly would be in a position to expand this entire phenomena for a raised to the a plus b raised to the power n, where n is an integral value. How would we expand it? So if I put it like instead of 4, I write it n. So I would write n c 0. And then obviously if I go to the earlier expansions, I would have to write it simply a n minus 0 b raised to the power 0. And then n c1 a n minus 1 and then b 1 plus n c2 a n minus 2 b 2 plus n c3 a n minus 3 b3 and so on. Possibly we can also insert one term here, general term NCR a n minus r br, and finally we write our term like NCN a n minus n and b n. So what shall we get? The final expansion would be a plus b raised to the power n as NC0 a power n plus nc1 a n minus 1 b plus nc2 a n minus 2 b square plus nc3 a n minus 3 b cube and so on. And finally, I would say what is ncr a n minus r b r plus ncn b power n. This would be the expansion of a plus b raised to the power n. I hope you must have understood this phenomena of expanding a plus b raised to the power n for the integral indices. And this expansion is what is known as binomial theorem. In my next video, I shall be teaching you various special cases and special aspects of binomial theorem to a more interesting outcome. If you want to learn more, you can contact me. My name is Dr. Ram Sharma. I can be contacted at my number 9654 502028. Thank you very much. We shall meet again.